distinct case. As our global community evolves and our elders become a more vital part of our lives than ever before, we bring you a solution born from care. We're proud to present the Safe and Sound, always there, always caring. So, what is Safe and Sound? Safe and Sound is a smartphone application that provides real-time health monitoring and emergency detection for elderly individuals. By combining wearable technology and AI-powered analysis, the app detects abnormal heart rate, low oxygen levels, and dangerous movements like falls. For the problem we are having, elderly care is a growing concern, and we identify three major problems. First, aging society. By 2050, nearly 2.1 billion people will be over 60. Many of them live alone and need better safety measures. Next, emergency risks. The elderly are prone to falls, strokes, and heart issues, but may struggle to seek help. And lastly, caregiver challenges. Family members and caregivers cannot always be present. They need real-time alerts and remote monitoring. Now that we understand the challenges, let's see how Safe and Sound provides the solution. First, we connect caregiver with elderly users, then track health metrics like heart rate, blood oxygen, and movement in real time, detect anomalies, and send instant alert in emergencies. Our primary stakeholders will be the elderly and caregivers. For elderly, many of them live alone and have medical conditions that make them vulnerable. Their needs include simple and clear interface with large buttons, accurate health monitoring, emergency alerts that can be automatic or manual. For caregivers and family members, they are responsible for monitoring elderly individuals, real-time alerts when something unusual happens, location tracking in case of emergencies, and a user-friendly dashboard. For secondary stakeholders are investors and healthcare providers, including government-related organizations and smart health hardware businesses act as essential infrastructure partners. And next are our core features. Smart and precaution notification. Send alerts to caregivers' mobile devices when abnormal patterns are detected, categorized into 3 levels. Emergency panics and alert. Enable the elderly user's device to emit a loud sound to help locate them in case of an emergency. AI-driven monitoring. Continuously track heart rate, blood oxygen levels, and gyroscopic data to detect abnormalities. User Management System, a comprehensive profile management module supporting distinct user roles. This system facilitates secure account provisioning, role-specific profile editing, and the management of dependent relationships. Real-time geolocation tracking, an integrated mapping interface designed to securely display the elder's current location to authorized caregivers. This diagram represents the Safe and Sound system. The inspected users interact with the system in a few key ways. They can provide their health data. It is through wearable devices, where it will send the real-time data to analyze. They can also trigger an alert, perhaps by pressing a button or if the system detects something unusual. The inspected user can view their personal health metrics, and they can provide their location data, which is crucial for monitoring their whereabouts. The system plays a vital role. It analyzes the health data, generates health alerts when necessary, and receives these alerts. The caregiver is another crucial user. They can view the inspected user health metrics, locate the inspected user, and view the inspected user information in general. This is a database diagram for our app. We have 2 core users, caregivers and elders, are connected to a relationship tables that link caregiver to elders. From there, caregivers can chat with elders via chat and messages. Elders' health data, location, and emergency alerts are tracked in real time. Finally, each user has their own notification and privacy settings. Everything is secure, only the right people can access the right data. We use file store rules to control who can access what data. It acts as a security layer, ensuring only the right users, like caregivers or elders, can read or write their own data. For the AI component, first, why do we use AI in this project? The Safe and Sound application incorporates an AI component that is central to its functionality of providing continuous health monitoring and automated emergency detection for elderly individuals. This component is designed to process and analyze physiological data streams originating from wearable sensors and enabling proactive identification and classification of potential health anomalies and critical events. We input the data, which are heart rate, SpO2, and gyroscope, into the AI model to find the slope-based outlier or anomaly detection, and then we expect the alert generation and emergency notification from the model. And next is the system architecture. We use React Native and build on Explore with the application part. Any request from the app part, which is on the left side of the pictures, will go into the Firebase and then be saved into Firebase services, such as the file store database or Firebase storage. After that, the AI model will retrieve the data and process it. Then return the output and save it back into the Firebase service. Lastly, the cloud function detects the status change from the database. It will send the notification to the client.
Next is the progress tagging. Let's begin with Progress 1. For the Progress 1 update, we are almost done with 80% of the UI parts and in progress with AI training. For the UI implementation part, we are 100% done with the system UIs, such as the authentication UI, and also done 50 to 75% with elder and caregiver UIs, such as homepage, notification page, profile page, and setting page. For the AI implementations, we input the data, which are heart rate, SpO2, and gyroscope, into the AI model to find the slope-based outlier or anomaly detections. And then we expect the alert generation and emergency notification from the model. And for the method training, it was 1D CNN because it is suitable for use with real-time data. Next is Progress 2. We are almost done with 95% of the UI part, 75% of the application part, and 80% progress with AI training. For the UI implementation part, we have completed more pages such as chat, elder information, notification to tabs, edit profile, setting, user management, privacy, and etc. Next is the backend implementation part. We have completed 7 to 75%. We have implemented functions like connect with Firebase, file store database, Firebase storage, authentication with email and Google providers, and enable cloud functions. But we still got the bug and error for some features such as chat, push notification, and alerts. Next is the deployment implementation part. We have built the APK app with the Expo EAS service.
Next, for the AI implementation, we built and trained two models. The first one was the 1D CNN, designed as a proof of concept to validate the which IMU data alone could detect false. It worked, but when we tested on the harder unseen data, we called up to around 76%, meaning roughly 1 in 4 false could be missed. That wasn't acceptable for a safety critical app. So we took everything we learned and built the model from the ground up, adding physiological sensors, temporary memory, and a full class output. The result is V2, which catches almost a perfect precision. Version 1 was a 1D CNN trained on sectional waste IMU data. It was lightweight, fast to train, but on the harder real-world test data, we called up to 76%, meaning it missed roughly 1 in 4 false. It also has no sense of time sequence, no heart rate or SpO2, and couldn't detect whether the device was even being worn. This gap pushed us to build a V2. Version 2 is a CNN by LSTM with attention. We expand the input to 11 channels, adding heart rate, SpO2, and derived motion features. The model now classifies into four risk levels, and critically, it detects fault via great precision in testing. It also correctly identifies when a device is being warned, so the system never sends false alerts from an unwanted watch. Side by side, the improvement is clear. We went from binary classification to four class list classification, from 6 to 11 input channels, and most importantly, from 76% to recall with great precision and a better accuracy. V2 is a model powering our 7 sound today, and even though there's still some minor bugs, we are still on the process on developing it more to be even better.
For our pending tasks, we need to do the alert page and some setting page for the UI part, fix the file-based error to make features like chat, notifications, and alerts work completely well. And we need to fine-tune the model for the AI part. And this is the summary of the progress and upcoming tasks. For now, we have completed 95% of UI, 75% of backend, and 80% of AI training. And for the next month, we will complete a whole project. Next, the demo of our project. Welcome to our demo. So let's begin with sign in with Google authentication. This is the caregiver role. So this is the caregiver homepage, caregiver notification page, the profile page. You can edit your profile, and the setting page. You can manage your account and set the notification. So I try to delete one of my elder, remove, then the notification will show, and the badge will remove. So I try to add back. So click add, request sent, and waiting for accept. It will show pending for a while. Okay. And this is the elder status. As you can see, the gyroscope status, heart rate, SpO2, and the risk. So next, we will try to change the status. So as you can see, the heart rate, SpO2, and gyroscope, and also the risk change into danger, and the color of the badge will change too. So this is the elder information page. You can see the graph and the elder information, but about the graph for now is not work well. So when you slide down to the elder information, you can see the location page alert. So if anyone has any questions, please feel free to ask. So please join us in making elder care safer and smarter with Safe and Sound. Thank you for watching.